Welcome to Science in the Field, the show where we interview scientists who are outstanding in their own fields, like I am right now. On today's show, we have a returning guest, Carina, an expert in giant branch stars. On today's show, we're going to be asking her about the details of these enormous stars that we find throughout our universe, how they got so big, and what their ultimate fate is. So without further ado, let's get into the interview. Thanks again for joining us today, Carina. I know you have a very busy schedule. Let's begin by talking about the different kinds of giant stars there are in the universe. Can you explain the 3 different types of giant stars we might find? Right, so there are blue giant stars, which are very hot and very young, energetic stars. We have red supergiant stars, which are what the blue giants turn into when they get old. And we have the red giants, which are what stars like our sun will turn into when they get old. So these stars can be hundreds of times the radius of our sun. How is it that they can be so large, even though they might start from something the size of our sun? Interesting. So these stars are using the process of fusion to provide themselves with energy and support themselves from gravitational collapse. But there's more than one stage of fusion going on, right? So it's not just the hydrogen burning that the main sequence stars have going. What other types of burning do these giant stars have? Right, so as they go through their lifetime, stars like our sun will produce lots of helium which accumulates in the core of the star. And eventually that helium gets so hot and dense that it too will start fusing to create heavier atoms like carbon and oxygen. So in the case of these massive blue stars, when they turn into red supergiants, how many different types of atoms can they fuse? Right, so they do the same as what our sun will do, burning hydrogen to helium, helium to carbon, and carbon to silicon and sulfur, and eventually ending up in iron, right? So these giant stars aren't all the same, won't have the same end. The red giant star that our sun will turn into, what will be the ultimate fate of that? So it doesn't have the mass needed to blow itself up. So actually, the fusion that happens in the different shells within the star overpower gravity, and eventually all of the outer layers of the red giant will blow away into space, creating a planetary nebula. But that's not the same for the enormous stars, which have too much mass and will eventually run out of fuel, right? Yeah, so those big ones are the ones that blow up, which we talked about last time you were on the show. So this has been very insightful, Carina. Thanks for coming on and telling us about the different types of giant stars that we have in the universe, and the ultimate end to all of these stars, with the blue giants turning into red supergiants, which blow up at some point, and small stars like our sun turning into red giants, which just puff away out into space. Thank you for your time, Carina, and I wish you the very best again for taking care of the giant branch stars. Come here. Yeah, I know you saw a birdie. Good girl.